Welcome to Algebra 1, Semester 1, Unit 1, studying for the final. If you are unfamiliar with the material from this class, then you need to go to the note packets and study that. I am only focusing on how to answer test questions, really testing strategies, analyzing what's offered. So, in Unit 1, here's the practice problem. Just some key vocab here at the beginning. What separates terms? Well, we should remember when we were doing polynomials, we had 3x plus 5, and we would say that there's two terms. It was separated by the plus. This is a term, that's a term. Now, it could have also been separated by a minus, but it couldn't be separated by a multiply, because I'll show you why. 5 times 3x could be worked out, distributed, and we would have 15x. So that's only one term. Multiplication will not separate. So you circle those as being wrong. Parentheses does not separate. It's only addition, subtraction that separates it. Okay, how many factors are in the expression below? Well, because B and C could end up being whole numbers, then we say that there's really just two factors. So we have one here and one here. We don't separate this time with the plus and minus simply because we aren't sure how that's going to come into effect. So two factors there until we know further about what B and C are equal to. Okay. Which of the following is a single term? This one has a minus, so that separates two terms. That's out. This one has a plus, separates two terms, so that one's out. This one has an equal, so that's an equation, so that leaves us with A. All that we have up there is multiplication. Evaluate the expression. That means that we plug in these values. So for A, we're plugging in -2. For C, we're plugging in 8. Now out here, be careful. Make sure that you plug in a -2. We have a negative from the formula, but then we have another negative for plugging in. Okay? On the bottom, we've got B plus C. Now we just go ahead and go down the PIMDAs to simplify that. So going down PIMDAs, doing parentheses first, -2 plus 8 is 6. 2 red ones. 8 yellow, you'd remove 2. So 6 squared minus a -2 over, we'll go ahead and put that together, 14. 6 squared is 36. Minus a negative, two negatives make a positive. 36 plus 4 over 14. 36 plus 4 is 40 over 14. We can reduce by dividing by 2. So we get 20 over 7. We have a problem here. I so apologize. This is how I sort through what I'm doing right and wrong. So let's just work with me. We put in a -2. We have a positive 8. That would be a positive 6. Minus a -2. That would be plus 4. That's where our mistake came in. That should be a +2. I apologize. So now we have 38 divided by 2. 38 divided by 2 would be 19. I don't mind making errors on here so you guys can see when I'm under testing conditions how I'd correct it and check it. All of these had 7 on the bottom except for A. That's what made it absolutely incorrect. And on these others, it's just the 5 and the 17 are not correct. Okay? Which of the following situations would represent 10 divided by D? We're looking for a divided by. There's the key word, divided by D. Okay, this is price per box. That would be a multiply. Additional 10 would be add, and total costs with a $10 discount would be a subtract on that discount. So, okay, parking lot holds 42 cars. There are 26 cars in the lot already. Which inequality can be solved to show the number of cars that can still be in the lot? I would think about this. If we've got a parking lot, there's 26 cars in it. Just kind of fill it up here. And it can hold up to 42. I would think through, well, how many more cars can I fit in there? 12 minus 6 is 6. 3 minus 2 is 1. So I can fit 16 more cars. Now thinking of C being equal to 16, I'd see which fits. 16 plus 26 would be 42, so that one would work, but we notice it has to be less than. Well, we can have exactly 42 cars, so we can mark that one out. Any others with just less than right there? Mark it out. So now these are less than or equal to. Would 26 plus 42 be less than or equal to 16? No. But 26 plus 16 will be less than or equal to 42. So I would just put that and then put a little note to see there. Levro works part-time for a moving company. One day he had to move 34 boxes from a truck to inside of a house. So he's got his truck here, and I always draw pictures. There's 34 boxes in here. And here's the house. He's moving them. Okay, after moving some boxes, he took a break and told his boss that he only had 15 more to move. So he has 15 more, and they're going to ask, how many boxes did he move before his break? Well, if he's got 15 left, 34 minus 15 would leave us with 19. He's got 19 boxes inside the house. So now that we're thinking about x being equal to 19, which of these would fit? Is 15 plus 34 going to be 19? No. 15 minus 19 going to be 34? No. 34 minus 19 equal to 15? Yes. 34 plus 19 equal to 15? No. Okay. Ayanna and Zoe measure the speed of a snail. Which units would be most appropriate? Okay, we're talking snail, not car, so it's not miles per hour. Minutes per millimeter, we should always have it per time. Per time is our units for measuring speed. So this is backwards. Per second, that one's fine. Meters per second, though. Meters is a lot for a snail, so we're going to mark that one out. Millimeters per minute. That might be more of a snail's pace. Which of the following represents a function? Remember, on a function, the x can only have one y value. He can't cheat. If we look here, we've got different domains. So there's no way for an x to cheat. So that one would be a function. Here we've got the same domain. Is he cheating though? He's with 6 here, he's with 8 here. That is not a function. He cheats. Here, different domains, so nowhere could he be cheating there. So that one is a function. So 1 and 3 are functions. That would make it C. Okay. Last 3 problems here. Which is not a function again. Again, we look at the x value. Is he cheating? We can see here with the vertical line test, he cheats. He's here and he's here. None of these others have a vertical line go through any point twice. So it is A that is not a function. John bought X pounds of beef for a barbecue. Price of the beef was $1.49 for the first pound. Okay. For each additional pound, it was $1.09, so it's $1.49 plus $1.09. For 3 pounds, it'd be $1.49 plus 2 times $1.09. Okay. So what I would recommend is you go through and you find your totals here. And then you can figure out which would be correct. Looking at what I've already done here, I can see that $1.09 isn't our constant, so that one's out. $1.49 has to be our constant, so that one's out. Because it doesn't have the $1.49 without the x. It's going to be all by itself, just like these are. Now here, we'd have $1.09 times the x value. The problem is that if you bought 1 pound, you'd be charged both the $1.09 and that. We don't want to be charged the $1.09 on our first pound, so we have to go with this. Because on your first pound, 1 minus 1 is 0, so it wipes that out and you have just the $1.49. I would highly recommend making a T-chart on that kind of problem. Next one, Jason has $40 in his savings account. He plans to deposit $20 into his account each month. By the end of January, so this is January, he'll have $60. February, he's going to have $80. So he keeps adding $20. March, he's going to have $100. And so on. Which equation describes the amount? Well, from class, when we did sequences into formulas, we knew that this was the slope, how much it's going up by, so that's 20m. And our starting amount, or our x-intercept, would be the 40. They wanted a of m. So we look for, there's our formula. Okay, this one has the wrong slope, wrong, so you could have eliminated it off the slope. Okay, that brings us to the end of Unit 1. Good luck studying for this final.